My research is about aging, and in this talk I was trying to understand why elderly people didn't respond very well to the vaccination. And as example I gave, it was about COVID-19. I'm working in mechanistic called autophagy, which we know it's very important for the function of the immune cells. And we see that this mechanistic goes down with age in different cells, including immune cells. So in my study, we were trying to see, can we induce autophagy and increase autophagy in the elderly and make them respond better to COVID-19 vaccination? And the primary data showed that it's really very promising, and we definitely could improve the immune response.
And you had a novel intervention that you were looking at that you presented at the end of the talk. Can you tell us a little bit about that, please?
Yeah, that's aging beyond the earth. Because I'm interested in aging, and the aging population has become bigger and bigger, so we are trying to identify a mechanistic and model that help us to accelerate our work. And the astronaut in the International Space Station seems to suffer from a different disorder like muscle atrophy that you are working on. They also have a problem with their bone and also with their immune system. And when we look at this, it looks like very similar to different age-related disease. And from there, we come with the question, do we accelerate aging in the space? Then can I use the International Space Station to do some experiment that allowed me to study aging in a very short time compared to the time, like in 2 weeks, maybe in the space, or 1 month in the space, something we have to study for 10 or 20 years in Earth. And other things really encourage us to go there, that most of the astronauts, when they came back, they reversed this mechanistic. So we might really be able to identify new molecule or new protein or something we have never been able to see it in Earth, because the change is very slow, while it would be more accessible or more obvious actually in the space.
Excellent.
So I would like to ask you to give me also an overview a little bit about your work.
Yeah.
And how it's relating to aging.
Yeah, so in the context of aging, we're interested in muscle, skeletal muscle, and how we can, well, first of all, understanding why we lose muscle mass at a certain rate with advancing age. And then secondly, focused on non-pharmacological interventions to try and intervene in that loss of muscle mass and function and strength. So primarily interested in exercise alongside nutrition, or the combination of the two interventions to try and offset that decline in muscle mass. And kind of aligned with your work, I suppose, we very much look at this from a whole body level, but down to a cellular level or a protein level. So interested in rates of muscle protein synthesis in response to these different non-pharmacological interventions, and also interested in muscle protein breakdown as well. So more aligned with your work, although in our hands it's much more difficult to measure in an in vivo setting. To directly measure muscle protein breakdowns, a really tough measure to do. So it's been great learning from some of the techniques that you've put up into your in your presentation.
Well, thank you so much, Oliver. This is really exciting, and I'm also excited to be here and see people and talk with them and see how actually the aging research is moved forward. How you feel being here today?
Yes, similarly, it's been a really positive experience. Great to connect with other researchers in the field of aging, not only within King's but also at Oxford and beyond as well. So it's been a great day so far, and look forward to more discussions just like this one.